Now, in case of the maximum shear stress theory, we still have the same two principal stresses, and now it says that the maximum shear stress should be less than or equals to SYT by 2. Now, we have normal stresses over here, so we have to transform these normal stresses into shear stresses to do this, right? So let's say that this is sigma 1, this is the Mohr circle, so this is sigma 1, let's say this is sigma 2, and this is the tau axis, and we have the Mohr circle like this. And in this circle, you can clearly see that the diameter, the length of the diameter is sigma 2 minus sigma 1. And so the length of the radius, or rather this, okay, this is also the radius, for example, and this is basically tau max. So tau max is nothing but sigma 1 minus sigma 2 divided by 2. So that is nothing but tau max, or rather we say sigma 1 minus sigma 2 divided by 2 is going to be less than equals to SYT by 2. So we cancel the 2's out. So essentially this is by 2 and by 2, but these 2's get cancelled. Let's say that sigma 2 is equals 0, and let's say that this normal stress does not exist. So for this sigma 1 alone, what will be the shear stress? So the Mohr circle will look just like a point. So this will be sigma 1, for example. There will be no second point, or rather the second point will be the origin, and or if this is sigma 1, then the second point will be the origin, and we will have this kind of a Mohr circle like this. And so the tau will again be sigma 1 divided by 2. And so if sigma 2 is equals to 0, we have similar equations to that of the maximum normal stress theory. So sigma 1 is less than equals to SYT, or rather the magnitude. We are speaking of the magnitudes, right? So sigma 1 is less than equals to SYT. Similarly, if we put sigma 1 is equals to 0, then we can have sigma 2, or this sigma 2 will be less than or equals to SYT, and we will have that same square that we had in the maximum normal stress theory. And now this looks essentially identical to the maximum normal stress theory graph. But then again, we have another equations, or rather two other equations, and that is going to be formed from this inequality over here, right? And from here, if I just say that none of the two normal stresses are 0, in this case, actually, if say for example I take the positive value of sigma 1 minus sigma 2, so that should be equals to or less than or equals to SYT, right? And then if I just write it like this, so I bring the SYT over here, then I write a plus instead of a minus, and I write this as this kind of a form. I'm just rewriting it mathematically, and this is essentially the intercept form of the equation of a straight line. So for sigma 1, the intercept is SYT, so this guy, and for sigma 2, the intercept is minus SYT, so it's this guy. And the line passing through these 2 points will be what this equation, or what the equation out of this inequality represents. So if I draw a line like that, so this is how that kind of a line will look. And again, and now if I take the other value, so now if I take that minus of sigma 1 minus sigma 2 is less than or equals to SYT, right? Or actually this will turn into sigma 2 minus sigma 1 is less than or equals to SYT. And if I write this guy in the intercept form as well, so that is going to be, so sigma 1 divided by minus of SYT plus sigma 2 divided by SYT is less than or equals to 1. And now essentially for sigma 1, the intercept becomes minus SYT, and for sigma 2, the intercept becomes SYT. So if I just drag this line over to there, we will have an equation like that. And my drawing is not really that good, because otherwise lines should have been parallel. This is the safe region when you are following the maximum shear stress theory.